Hi, good afternoon. I hope you are well. In the few decades, researchers have shared the idea of swapping common fossil fuels. I also think so. Therefore, I'm going to talk about soybean oil hydroprocessing for biofuel production, where the addition zinc oxide to alumina support showed, showed increased the activity catalytic. Moreover, at pH 9, increasement nickel molybdenum interaction promoting hydrogenolysis. But well, my name is Alexis Mijares Alvarado, and I am a student from the Universidad Autónoma of Hidalgo State, and I was working under the auspices of the Dr. Alfredo Guevara. The addition of zinc oxide will improve the properties catalytic of the alumina. Some properties of zinc oxide are pore support, mechanical strength, stability the active phase, biodegradable, low toxicity, and thermal stability. Gain the new support. The properties of the new support must be high porosity and superficial area. Increase nickel molybdenum interaction and decrease nickel support interaction. Aim. Evaluate the synthesis of nickel molybdenum catalysis support on alumina zinc oxide in soybean oil hydroprocessing for biofuel production to know the effect of zinc oxide on catalytic activity. In the preparation of catalysts, the support were prepared by the salt head method. First, isopropoxys were dissolved in propanol. The gel was obtained through hydrolysis. The gel was then dried at 120 degrees Celsius for 4 hours and calcined at 400 degrees Celsius for 4 hours. The support were ground. The catalysts were prepared by wetness co-impregnation with 14% weight molybdenum trioxide. Two impregnation solutions were prepared at pH 5 and pH 9. The catalysts were dried at 120 degrees Celsius and calcined at 400 degrees Celsius for 4 hours. Now, the support surface characterization was carried with set potential to determine their net surface pH. The salt gel alumina support showing a net surface pH of 7.8, whereas alumina zinc oxide exhibit a net surface at pH of 9.9. The increase of the net surface pH of alumina oxide zinc oxide support is associated with the isoelectric point of zinc oxide. This figure shows nitrogen absorption desorption isotherms of alumina support and correspond to type 4 isotherm and type H2 hysteresis, which are characteristic of mesoporous cylindrical with uniform size and shape, showing that the salt gel support synthesized have better properties than industrial support. The reflectance diffuse spectroscopy allowed to study the oxidation state of the support and the nickel local symmetry. The UV-Vis-GR spectra of the nickel molybdenum alumina at pH 5 and pH 9 exhibit bands which are associated octaedral molybdenum. This catalyst dried showed nickel with octaedral symmetry, and calcinate showed nickel with octaedral symmetry distortioned. On the catalyst supported at pH 5 have increased nickel-alumina interaction, hence low catalyst activity. The UV-VSDR spectra of nickel molybdenum alumina zinc oxide exhibits a bands associated octahedral molybdenum. Shows nickel with octahedral symmetry, and when the catalyst is calcinate, show octahedral nickel distortioned symmetry. On the catalyst supported at pH 5 have increased nickel-alumina or nickel-zinc oxide interaction, hence low catalyst activity. The free fatty acids and triglycerides concentration were measured by infrared spectroscopy. The triglycerides concentration was measured using a linear calibration of the area of the carbon oxygen stretching vibration band, and the free fatty acid concentration considering carbon oxygen stretching bands of the carbonyl group. The carbon oxygen stretching vibration bands of the star group is at 70-40 centimeters at least 1 for the triglycerides concentration, and the carbon-oxygen stretching bands of the carbonyl group is at 70-10 centimeters at less 1 of the free fatty acid. The catalysts were indeed first activated by sulfuration with 4 liters per hour flux of 10 mol% sulfuric acid in hydrogen mixture at 400 degrees Celsius for 4 hours. In the catalytic evaluation was performed in the fixed bed continuous flow microreactor with a 0.4 milliliters per minute flux of soybean oil at 10% in eptane, with 0.05% of dimethyl disulfide, as well as 35 milliliters per minute hydrogen flux were fed to the reactor containing 0.1 grams of previously sulfide catalyst. The reaction was carried out at temperature between 360 degrees Celsius and 410 degrees Celsius at 40 bar hydrogen pressure. The reaction mechanism occurred during the catalytic hydroconversion of triglycerides. The first step is the hydrogenation of the carbon-carbon bonds of triglycerides followed by a carbon-oxygen hydrogenolysis reaction, leading to the formation of the 3 moles of free fatty acids and 1 mole of propane. In the second step, oxygen atoms from fatty acid molecules are removed in order to form light chain hydrocarbons through a deoxygenation reaction. Free fatty acid deoxygenation can occur through 3 main mechanisms: deoxygenation, decarboxylation, and decarbonylation. In the hydrogenolysis reaction, the evaluation of the rate constant hydrogenolysis shows increase in the catalyst activity of the synthesized catalyst with respect to the reference catalyst. In the higher hydrogenation triglycerides conversion, the rate constant of the free fatty acid deoxygenation increases. Only nickel molybdenum catalyst and alumina zinc oxide support at pH 9 decrease. Also shows higher free fatty acids conversion. In summary, all of the synthesized catalysts show higher catalytic hydroconversion of triglycerides with respect to reference catalyst. The more active catalyst of this series is the nickel molybdenum alumina zinc oxide impregnate at pH 9. In conclusion, the addition of zinc oxide to alumina salt method allowed us to obtain inadequate support for hydroprocessing, whereas the impregnation solution did not influence in the local geometry of our nickel molybdenum, having nickel octahedral symmetry and molybdenum octahedral symmetry were observed in all catalysts. Also, the lower activity was related to nickel zinc oxide or nickel alumina spinel, thus lower nickel molybdenum interaction. And the addition of zinc oxide increases the activity catalytic nickel molybdenum catalyst, increases of hydrogenolysis, triglycerides, to free fatty acids. Acknowledgement. The CONOCID program finished this project and my fellowship and International Material Congress Research 2022 for the invitation.